This is my Gen 4 6-liter Chevy truck motor. It's an L96. It's essentially an LS2 bottom end, but in cast iron with LS3 style heads. The head casting is an 823. I've already rebuilt those or freshened them up in a previous video. 823 heads are exactly the same as an LS3 casting. The difference being that the truck heads do not have a 3-angle valve job. They only have a 2-angle, and they have solid valves, not hollow stem valves, and different springs from the factory. But port size, chamber size is all the same. So this being an LS2 block, but in cast iron, it has a 4-inch bore, a 3.6 and some stroke, for a total of 364 cubic inches. I have already cleaned the block, took it to the car wash, cleaned out all the oil galleys, got the plugs out, including the dumbbell, and I have honed the cylinders and pushed out the cam bearings and put in new cam bearings in the new cam. I am not taking anything on this to the machine shop. It's all going to be done here in the garage. There was a little bit of a ridge around the top of the cylinders where the rings would come to a stop at the top of the bore. I took that down by hand on all cylinders, and today I'm going to be fitting and filing rings and then installing pistons and the crank with new bearings. So original pistons, rods, bolts, new crank bearings, new rod bearings, new cam bearings, new rings, and then I'll put it back together. So a little trick of the camera, I've been building my 6-liter Subaru, which is not actually a 6-liter. That one is just a 4.8 block for mock-up. This is the real motor for the car, and it's never been in the car. When I file rings, I like to push the bottom ring, and you can tell it's a bottom ring because it's got a little lip on the bottom of it, and it has a dot on the top, and the dot on the top always faces up. This is a ductile iron ring. It's a Moly coated. I think they only coat it on the face though, and Moly color codes the edges of their rings so that it's easy to keep track of them while you're doing assembly. Blue for bottom, red for top. Oil rings, of course, are skinny, so everyone knows what they are. So this one has a machined lip on the bottom. That is supposed to give better seal and better oil control. I'm sure it works. So when you fit the ring, take the gap area in your hand, push the ring in, that way you don't scrape the bore with the open part. Then take the piston. I like to push the piston all the way into the bore where the skirt is even with the deck of the block. That way I'm sure that the ring is square in the bore. One finger on each side, you know it's true. Take the piston out, and good old cheapo feeler gauge. I think we're at about 16 or 17 thousandths on these rings by eye. 16's a little bit loose. 17's a little tiny bit loose. And 18 is tight. So we're at 17 to 18 thousandths on the rings. I am going to aim for 30, 31, 32 thousandths. They should be as even as possible. Of course, they will not be perfect. So anything in the 30 to 32 will be acceptable. Now, Mahle recommends 0.008 or 8 thousandths of an inch on this set of rings for forced induction high performance applications. It is a stock style ring. We do know that stock Chevy LS rings will put up with over 1,000 horsepower. I would have reused my stock rings, except one of them broke when I was taking it out of the piston because of too much carbon buildup. The piston was not damaged, but the ring was broken. And if you have to do one new ring, you might as well do all of them. If you don't have to do any, don't do any. So now I'm going to get this out and I'm going to put it on the ring filer and start opening it up to get 30 thousandths. This is the ring filer. I use my portable vise for a lot of things. It makes moving things around the shop a lot easier. The technique with the ring is that you put the ring into the ring filer. It will butt up against the two guide pegs and you squeeze the ring together. Some people like to file one side, some people like to file both. The ring filing machines that are automated with gauges on them can be set up to do either one side or both sides. I'm kind of low tech on stuff. I know this works. It's not real fast, but you know, the thing about moving slow with tools like this by hand is you're far less likely to overdo something, which means you aren't going to have to end up ordering new rings because you messed up and made them too big. And if you do gap your rings bigger than you think they should be, don't run them, get new rings, put them in. So I'm going to start off with this one. It's probably going to take about 12 turns, that's my guess. And the rule on the ring is that you always file from the outside of the ring towards the inside. Haven't done this in a couple of years, so I gotta practice my technique. Yep. Light touch like that. So that took me 4 thousandths. So it went from 18-ish to right at 22. So that's the technique. I'm going to do all of them and then come back and show them to you.
get it hot. Certified sunshine, we got it on lock. Loving you forever, ever, until I forgot. I said I need less talk, a little more space, and need to know my feelings, but my words get in the way. I never really think straight, and you walked away. I ain't good at noticing, I know I gotta change. I heard you're back in town, you're coming around. I know I did before, but I'll never let you down. I see you looking my way, I felt the wind change. We can try again and make it summer every day. I know you've been down, I'm still the one in your heart. But we could get together and we'll never be apart. I wanna get down and restart. Everything we do's a work of art. Hey, baby, heard you want some action. Hey, I'm on my way. Yeah. Come on. Hey, baby, heard you want some action. Hey, I'm on my way. Come on. I made a friend on the block. He's everything I'm not. Slick like a flame and fresh as easy rock. I said, how do you do it?
Take everything in stride.
When the world don't vibe, you gotta go with what's inside.
I said, break your chains, stop running in place. Throw your inhibitions out with all your some days. I'll get you, girl, make her your world. Come back, but get out of your head, fool.
Been living in the sun, every day a new one. Feeling brand new, like my life had just begun. I see you looking my way, I feel the wind change. We can try again and make it summer every day. I know you've been down, I'm the one in your heart. But we could get together and we'll never be apart. I wanna get down, everything we do is a work of art. Hey, baby, heard you want some action. Hey, I'm on my way. We could get together and we'll never be apart. Come on. Hey, my baby, heard you want some action. Hey, I'm on my way. Come on.
I put the rotating assembly in my 6-liter together. Everything is torqued to spec. Now I'm going to work on putting the cam retainer plate, timing gear, and oil pump on the engine. A common question when rebuilding an LS based motor: can you reuse the cam thrust retainer plate? The answer is no. There is a very thin injected gasket on the back of the plate. It goes where the lifter galley, oil galleys are. You can reuse it. I would not. It is cheap, and if you don't have oil pressure here, then you have no oil pressure. So, your choice. I buy a new one every time. Can you use RTV? No. You can, but don't. So, buy a new plate every time. This is not how I normally wrench, but I'm doing this to make it more visible. So, now the cam cannot slide out of the front of the motor, but it could still slide out of the back. There's a torque rating on these fasteners. I don't know what it is. Doesn't matter, I guess. And that's it for that part. So for the motor build, I opted to use stock pistons and rods. It's a Gen 4 6-liter. Supposedly they're strong enough to handle over 1,000 horsepower easily. I did replace the timing gear / oil pump drive on the crankshaft. I did that because I'm using a new oil pump. This was a variable valve timing motor, but did not have displacement on demand, or AFT, active fuel whatever nonsense. So since the oil pump is new, I decided to get a new drive gear. That's not necessarily required, but I thought it would be a good idea. I'm using a Cloys 4X timing gear. This is a 58X timing crankshaft, so 4 and 58. I ordered a C5r double roller timing chain. Supposedly it's the strongest one. Chevrolet and Cadillac both use this in their Le Mans cars, so it's a Chevy performance item. All these parts, I'll put the link in the description of the video, and you guys can get on Amazon or elsewhere and buy them, but I'll put the link to Amazon. The other thing on the variable valve timing and displacement on demand motors, if you go to a standard timing set, you need to get an LS2 style tensioner. The displacement on demand or AFM, active fuel management type tensioner, does not work properly with this type of gear. So this is what you need right here. So here's how it goes on. And of course, magic of TV, I already test fit everything to make sure it was good, because I like it to look like I know what I'm doing. Sometimes, even when I know what I'm doing, it looks like I don't. So there's the timing tensioner, and it's not really a tensioner. What this thing does is prevent the chain from slapping around. It is a wear item. Now, since the engine rotates clockwise, this side of the engine has tension as the crank pulls, and this side is loose, so this is the side that's going to wear, the what would be the passenger side of the vehicle, or the even number cylinders. So, as I said, I test fit this. There we go. Already doing it upside down. Now I don't look like I know what I'm doing. Just like that. There's the timing assembly. I did opt for some ARP bolts for this. I also am going to be using ARP head bolts. Everything on the bottom end is original. When you use studs, it causes the block or the head or both to flex different than original. There's the timing assembly. So I'll torque everything down. These are 18 or so foot-pounds, and these are 25. So I'll give both of these a shot, and then we'll move on to the other stuff on the front. This is a Melling 10295 oil pump. It is a stock replacement for an LS1, LS2. It makes 10 psi more than stock, which is 70 psi rated. That means that using the 10 per 1000 RPM rule, this oil pump should support 7000 RPM. Melling 10295, a little bit of thread locker blue on the bolts, 20 to 25 foot-pounds of torque. They talk about aligning the pump. Some people do it, some people don't. I've already slipped it on and checked on how much clearance there is. It is very, very minimal, like 0.002. To align it, you take the cover bolts off once you slide the pump on, and then you put some feeler gauges in there on the sides to get everything lined up. It is such a minimal amount, I'm not going to do it. If you think I should, tell me why, and I'll go back and redo it, but I don't think it needs to be done. So there it is. There are different front cover alignment kits available. I like this one. It has a fake oil pan rail. The way it works is that it basically acts as a straight edge across the bottom of the block, and it has bolts for the front cover so you can get the bottom of the cover lined up exactly for an oil pan. The other part of the alignment kit is this donut. It slides on the crankshaft. It is machined for a double keyway, so it'll work on LS7 and LS9 and LSA motors, or any aftermarket crank. So this tool is neat in that it simulates having an oil pan. So, front cover gasket, front cover, you do it without the seal in it. Some of these are sold with the seal already pressed in. If so, you have to press it out. The best way to do this is to get your bolts and start your bolts in the holes through the gasket. Depends on where you get the gasket, but some of the gaskets squeeze in slightly, so you have to go one bolt hole at a time. There's probably a trick to this. I don't know what that is, but you can see the gasket does not fit exactly, so the gasket has to be pulled out. I'm sure that's part of the design on purpose. So what I'm going to do, grab the tool, and use the bolts to pull the gasket into place. There's the gasket on the cover. I forgot a thing. Good thing I caught myself. I need to put a galley plug in here. Here's one of those, for lack of a nail, the war was lost moments. I forgot to order an expansion galley plug. This is the oil galley. I measured it with the calipers. It's 0.6305 to 0.633, depending on which angle I measure at. So I went to the store. I bought an LS Gen 3 galley plug. They don't have one listed for a Gen 4, and this is why. The Gen 3 galley plug does not fit a Gen 4 engine, at least not this one. So I took one of these galley plugs, put it over the top of a tapered socket, smashed it a little bit, and now I got one that fits, and I can tap it in and it'll be snug. I did not order a complete galley kit because I did not take the screw-in galley plugs out, and I already ordered a billet barbell for the back of the block, and I didn't want to spend the money for a 59-cent plug and waste the rest of the kit. So Gen 3 plug in a Gen 4 block does not work. So Gen 3 plug, slightly expanded, does fit in the block. I'm going to put this in with some blue Loctite, make sure it's nice and snug. It's about 4 hours of my life right there wasted looking for these things online, looking at the local parts places, and a really simple, cheap solution. So all in, 59 cents. But absolutely necessary part. So I'm going to tap that in there, and then I'm going to put the head gaskets and the heads on the block. The head gasket surface is all prepped. I put the dowel pins in. I clean the head gasket with brake parts cleaner before installation in all cases. I use the non-chlorinated. It's marked front. These gaskets can be flipped over left to right because the heads are symmetrical. So place the head gasket over the dowel pins. Now, since I didn't send this block to the machine shop, I'm going to put the cylinder heads on the same side. On motors that go to the machine shop, that's not as critical. So, let's see if it fits like it should. just like original, perfect fit. So drop a bolt in temporarily just to secure it. Now I bought ARP bolts. They are supposed to be better than stock head bolts. The shank of the bolt is larger, threads are the same, head's the same. It does have a nice shoulder and a thicker shank. So I'm gonna get my washers ready and get the ARP assembly lube ready and then put these all in. Of course I have to remove the rocker arm and the rocker arm stand first, but I just have it all together to keep everything organized. The major components of the 6-liter are done. Heads are on the block. Block is fully assembled. Front cover is on. Crank seal is in. Timing gear, timing chains, the timing tensioner. I still have to put on the rear cover and the rear seal. Of course, my oil pan is in the car on the mock-up block, so for now it'll have no oil pan. I still have to measure the pushrod length, so for now the rocker arms are all loose with no pushrods in the motor, but the lifters are in, the lifter trays are in, head gaskets, valley cover is in with new seals. So next up for the motor, I am going to do the rear cover, test fit my flywheel and clutch. I'll temporarily put an oil pan on here to cover this up. just so I don't get debris and things in it. And then I will get back to doing more fab on the car. Thanks for watching.